Here is a simple example. Let's find out what is the area of the region bounded by the curves 8x minus x squared and cosine x plus 5 between x equals 2 and x equals 6. First thing we have to do is we have to figure out what this region looks like. So we can do that with the use of a calculator, unless the functions are really easy, in which case we can do them by hand. But using a calculator, this is what the region looks like. Now what we have to do is we have to find out which one is which curve, right? Because we have to identify which one is the top curve and which one is the bottom curve. Well, from the shape we know that the blur curve has got to be the cosine x plus 5 because of its undulating pattern, and on the other hand the red curve definitely looks like a parabola, so it has to be the 8x minus x squared, which means that the parabola is on top and the cosine x plus 5 is the bottom boundary. X equal 2 and x equal 6 are the two left and right limits, so they're going to be our a and b in the integral. So what that means is that once we slice it up, we end up with our area being given by the integral from 2 to 6 of the areas of each rectangles. The area of each rectangle is going to be given by the height, which is the difference between the two functions, with the parabola being the first one, times dx. At this point what we can do is we can use the fundamental theorem of calculus and say, well, that integral is going to be given by the antiderivative of that function between 6 and 2. And at this point all we have to do is compute or evaluate those two antiderivatives at 6 and at 2, and they will give us these particular numbers, and then we can put all those in the calculator if we want to and end up with an actual approximate value of 39.86. Now this is approximately alright, but only approximate in the sense that we have done some rounding in the computations of sine 2, sine 6, and 8 over 3 and so on. However, we can make this approximation as accurate as we want by simply cutting off as few decimal digits as possible. Now, why is it important to get this decimal value? The reason for that is to make sure that in our calculations we've done everything at least reasonably, and that there is no blatant error that comes up on this number. Notice, for instance, that this region has a width of 4 and a height that goes all the way from 4 to 16. So, well, it's about 12, right? But 12 times 4 is 48. But of course 12 is, if you want, the highest height, the biggest height that we can get. So we can expect an area which is a little bit less than 48. So the 39 sort of makes sense. So just like in many other situations where we've done this, we can use the approximate value given by the calculator just to check that the order of magnitude, the size of our answer, makes sense. Otherwise, all we've done is we use the four-step procedure, the fundamental theorem of calculus, and have obtained the exact area.